In this video, I'd like to talk about the change of base rule for logarithms. And before we jump into these problems, in previous videos, we've looked at the case where maybe we had log base 2 of 8, and we could actually evaluate this by just thinking it through. Since if we let this equal some variable x and we rewrite this in exponential notation, so our base of our exponential expression would be the same as the logarithm. So base 2. The logarithm is equal to that missing exponent. So it would be 2 to the x. And whatever's on the inside of the logarithm is what your exponential expression is equal to. So we ask ourselves, what do we raise 2 to get 8? And you can recognize that 8 is really just 2 to the third power. So in this case, x would be 3. Now, this works if it's a whole number, or even if it's a fraction, that would work as well. But if this is some irrational number, then this becomes very difficult to do this way. In fact, it may even not be possible. So as an example, we could look at log base 2 of 7. And the question is, how would you think about this? Since if you rewrote it, this would be 2, if we call this y, this would be 2 to the y is equal to 7. So what do you raise 2 to get 7? Or what power do you raise 2 to get to 7? And it's not going to be a whole number or a fraction. In fact, if we want to know the exact value, we need to use the calculator. And in this video, I will explain how to actually approach this. Since the power we would raise 2 to would be this 2.807, and like I mentioned, it's going to be irrational, so it's going to go on forever in its decimal expansion without a pattern. So what is this change of base rule, and how does it apply to a problem like this? And in this video, I'm not going to prove the change of base rule, I'm just going to show how it works. And the general idea, I'll write it abstractly first in its general notation. But the idea is that if we have log base a of b, that we could rewrite this as a quotient of two logarithms, where we can change the base of these two logarithms to whatever we want, as long as it's the same in the top and the bottom. So let's call it base c for now. So this will be equal to log base c of the input of this original logarithm, so we'll put the b there, divided by log base c of our original base. So log base c of a. And this probably will seem very abstract at first, but let's look at a concrete example. So if we had, in our case over here, this log base 2 of 7, we want to change this so that it has a base which we can put into our calculator. And the calculator has two primary logarithm buttons that we can use. This log button here and this ln button here. Now, the log button assumes the base of the logarithm is 10. We call this the common log. The ln button, this is a logarithm with base e, where e is that number 2.718, and it goes on forever. It's an irrational number, kind of like pi. But the logarithm has these two buttons. And some calculators have a third button where if you hit the math button and you scroll all the way down, you can find this log base of something. And in this case, you can customize your logarithm. So we can put in base 2 of 7, and you'll see that we get that answer we saw before. But for other calculators, it's not going to have a button like that, so we want to just rewrite this. Let me actually put this down here, using either the common log, which is base 10, or the natural log, which is base e. So let's use the common log. So we can rewrite this. And again, we can make it with any base that we want, but most of the time you're going to use base 10 or base e since that's what the calculator has. So we'll use base 10. So log base 10 of the top number, 7, this input of the original logarithm, divided by log base 10 of the original base. So we'll put 2 there. And with the common log, we can just omit this base 10 here. It's implied. When we write log 7, it's implied that the base is 10. And we'll divide this by log 2. And you can put this into the calculator. And what you'll see, so we'll have log 7 divided by log 2, is that we get the exact same answer. And we could also use a different base, like I mentioned. We could use the natural log. So with the natural log, you write ln of 7 divided by ln of 2, where when you see this ln, that's really just log base e of 7 divided by log, let me make some more room here, base e of 2. And remember that number e, it's an irrational number like pi, but it's equal to 2.71828, and it's going to go on forever in its decimal expansion. But we saw if we want to approximate these, because we're not going to be able to write out the whole decimal, that this is equal to 2.807. We'll go to the thousandths place, 2.807. So this change of base rule is incredibly useful. And we're going to apply it to several different example problems. So let me just make some space very quickly, and then we can jump into these problems.